Hey everyone, today I am going to show you a project I have been working on. A LoRa based Morse code transmitter and receiver built with the ESP8266. This project lets you tap Morse code silently on a glove using a force sensor, transmit it wirelessly over LoRa and get feedback with a buzzer or vibration motor. Let's check it out. Here's the hardware I used. An ESP8266 NodeMCU board, which is the brain of the system. A LoRa SX1278 module for long-range wireless communication, a force sensitive resistor that registers dots and dashes, an eccentric rotation motor for vibration output, which I have used in this glove over here, and for this node I have used an LED because the vibrations can't be shown in a video. For the scope of this video, I will refer to the receiver mode of LoRa module as RX and the transmitter mode as TX. So I will first explain the working of the nodes. Let us say this is node A and this is node B. So first I will make this node as TX. So I will press the FSR sensor for 6 seconds and it will go into TX mode. The TX mode is denoted by the glowing LED on the board, and then it is registering all dots and dashes through FSR sensor, encrypting it, and the LoRa module is transmitting it to node B, and here it is decrypted and the output is given through D1 digital pin, and in this case eccentric rotation motor is connected, so it will give output in vibrations, and in this case there is LED. So now for the demonstration, first I will convert this node into TX mode. So I will press this FSR sensor for 6 seconds. And now I will register dots and dashes, and this is being transmitted to node B, and we can sense vibrations in this glove. If I keep this FSR sensor idle for 5 seconds, the node will automatically go into RX mode and a LED pulse will be generated. This is part of the feedback mechanism. When the node is in TX mode and it is kept idle for 5 seconds, it will convert back to RX mode. But just before it converts back to RX mode, it transmits a S. The S is transmitted to the second node, and the second node triggers the acknowledgement and sends Y if it receives the S, or if the S is not received, it doesn't send anything. And this node, after converting to RX, searches for 1 second for any kind of signal which relates to Y. If the node gets Y, then it concludes that the transmission line was connected throughout the transmission and the transmission was successful. So it beeps with one blink which says successful transmission. If I disconnect this node, so the transmission is hampered, and I again convert this to TX mode and I try to send signals, and I rest FSR sensor for 5 seconds. There were 3 blinks. This says that the transmission line was damaged during transmission and the transmission was not successful. This is because this node never got the Y which it was searching for the first 1 second when it got into RX mode. This time I am using this node for going into TX mode because this is being connected through a data cable which has a data line, so we can see what is happening in all this. So I will first convert it into TX mode. Now you can see that it is sending 16 bytes of data every time, but dot and dashes only make 1 byte of data. So why 16 bytes? Because AES library convert the 1 byte of data into 16 bytes of data through multiple layers of XOR, and it sends the final output with the key so that the other node can decrypt it, but no one else can access the data or find out what is being transmitted. This is all for the video, and the link for the GitHub with the code will be given in the caption, and the list of hardware will also be in the caption, and thank you for watching.